All right, today we're going to be doing Unit 6, Lesson 22 notes. So in this one, we're going to be talking about graphing sets of points and creating a scatter plot based off of this, and then using regression to be able to come up with an equation that will make predictions based off of the equation that you came up with. So essentially what we're going to do, create these scatter plots. I'm going to show it with Desmos. If you want me to show you using the calculator, I can do that as well, but in the notes here, I'm going to show it to you on Desmos. I think it's a little clearer when you do that. So let's start off with some of the basics. First of all, scatter plot is just literally on a graph plotting the points that you're given. You're going to have an independent and a dependent variable. Your independent's going to be your x, and your dependent's going to be y, like it always has been. And then based off of that, we're going to come up with a correlation. And that correlation, which Desmos and the calculator would give you an exact value for it, but what we're going to do with correlation is we're going to look at the scatter plot and decide, is this a linear grouping or not? And if it is linear, is it a pretty strong correlation? Is it not a strong correlation? Is it positive? Is it negative? And so on from there. So let's go through what some of those pictures would look like. So after you plot the points, you're going to look at them and say, well, can I basically draw a straight line through them? And if I can, then it's going to be a strong correlation. And if I can't, then it's not. So like, for instance, this one here, if I would draw a line. Now, again, technology would give you a more precise, but basically, this is going to go through the points sort of like this here. And you see that line doesn't hit, the points aren't on that line completely, but they're pretty close to it. And they go in an upward direction as you go to the right. So it's going to be a strong positive correlation. It's not exactly a line, but it's pretty close. This one here is even closer. Oops, sorry, that was a terrible line. And because I'm going down and to the right, that would be a negative correlation. This one here, where would you draw a line on that one? Not, really can't do it. So that's why this one has no correlation, or almost none. I mean, again, the calculator will draw a line through it, but it won't be a very good one. This one here, this is going slightly up and to the right, as you can see, something like this. That's pretty weak. And the same thing with this one. As you see these points here, they're going down to the right. But again, not very well. So that would be a weak correlation there. All right, so think about these two here. And what do you think? What type of correlation do you have? Is it negative? Is it positive? Or none? And if it is one of those, then is it strong or weak? So this one's definitely positive. It's going up and to the right. This one you could probably make an argument either way. I would say this is decently strong. It's not great, but it's not terrible. Whereas this one here, this one's a little bit better. This one's kind of all over the board a little bit. Not like these were over here, but so that's why I would say this one's strong, and I would say this one for negative is strong as well. You can argue those a little bit. Again, when we use the calculator, it's going to give you a definitive number behind that. That's a little bit easier to tell. All right, speaking of the calculator or Desmos, like I said, we're going to use here, you're going to come up with a correlation coefficient. It's going to be R. And that R, what we're looking for is for it to be, it's going to be somewhere between -1 and 1. We're looking for it to be as close to 1 or -1 as possible. So if this correlation does equal 1, correlation coefficient, this R does equal 1, then it is a straight line with a positive slope up and to the right. If it's equal to -1, then it's going to be a straight line down and to the right. And if you have something like 0.95, it's almost a line, but not quite here. And same thing with this one here being negative. Whereas you see when they're more spread out, they're going to give you numbers that are not exactly 1 or -1. They're going to be a little bit off. So the further away you get from -1 and +1, the worse the correlation is. Now, for a cutoff, there's no exact cutoff, but somewhere around zero 0.9 and above would give you a pretty strong correlation, and anything below that starts getting weaker and weaker and weaker. It doesn't mean 0.91 is strong and 0.89 is not. I mean, those are pretty close. So it's not that cut and dried, but again, the further you get away from one, the worse it is. All right, so I'm going to show you then how to do this on Desmos. This would be the steps. You're going to input your list. You're going to move your graph so you can actually see the points. You're going to type in this equation here to be able to come up with the line. And then you're going to write your equation and you're going to analyze it as needed. Now, when you go to make your list, the list should come up as X1 and Y1. But if you then put in another list without like going to a new window, it might come up X2, Y2, or X3, Y3 or something. You would need to change those ones to twos or threes or fours. You need to look at the top of the list of what it says. So I will show you how to do that. Okay, so let's say we have this one here. Anthropologists can use the femur, thigh, or thigh bone to estimate the height of a human being. The table shows the results. Here they are right here. So we're going to create the scatter diagram, then we're going to come up with the equation, answer some questions off of that. All right, so on Desmos, so to make a table, you go to the plus sign, go to table, see how mine says X1, Y1. If it says something different, then you need to adjust when you make the equation. So length is going to go in as X. Type those in, make sure just like when you type stuff on your calculator that you're careful with the numbers, don't mess any up like I just did there. Okay, there's the first column, second column. All right, so assuming that you're using your Chromebook, you have a touch screen, so you can adjust your screen like this. See how I'm taking just the X and changing that there. So I think that looks pretty good there. So you see we have a pretty strong positive correlation between this. It's not going to be exactly a straight line, but when we do the equation, you'll see that it'll be pretty close. All right, so the next thing I'm going to do then is type in the stuff for the regression equation. So that would be y1, use the tilde, and then we type in ax1 plus, okay? So you see we have a r of 0.986. R squared is if we're comparing this with a curve as well, which we're not going to be doing. So we're just going to be worrying about r here. So 0.986, pretty close to 1. You see the line here, pretty close to the points. So then our equation is going to be, we're going to use y hat. And when you make a regression equation so that you're identifying that that's the symbol that's used along with that. So y hat is equal to, we're going to round 2 decimal places, 2.91x plus 54.04. You're going to see a lot of times that the 54.04 will be written first. So it'll be written like I hat is approximately 54.04 plus 2.91x. Doesn't particularly matter which one you write first. Going forward, I'm going to write it most of the time with the y-intercepts first and the slope second. All right, so 0.986 for our correlation coefficient, pretty close to 1, so that's very strong positive. And then the question says here, interpret the slope of the line in context of the problem. So the slope, 2.91. But basically what that means is every time x increases by 1, y would increase by 2.91. Or if we're going to use the language of the problem here, every time the femur length increases by 1 centimeter, the height of the human being would increase by 2.91 centimeters. Right, and then the last thing, if a man's femur is 41 centimeters long, predict the man's height. So I would plug in the 41 in for the x, solve that, you get 173.35 centimeters. All right, so that is, oops, actually no, one more, sorry. So just as another example here, if this were this is gas mileage based on engine horsepower. So here's your horsepower, here's the mileage that you get off of that. So I made a scatter plot of this. I use the calculator on this one, but again, on Desmos, it would look about the same. This one looks more like a curve. When you think about it here, if your horsepower goes up and up and up, at some point, if this were linear, this would go below the x-axis. That doesn't make sense. You can't really have negative mileage on that. So, is this a curve? So, I would say it looks pretty linear in a negative direction. I don't know if it's the strongest correlation in the world, not quite as good as the previous problem, but we'll have Desmos back that up on that. So I then plugged in the problem into Desmos and got this for the line of best fit. The coefficient on this one was negative 0.916, so decently strong. Again, not as good as the last one. And then interpreting the slope again. So if the slope is negative 0.15, every time the horsepower increases by 1 unit, the gas mileage will drop by 0.15 miles per gallon. And then if I plug in 210, I would get 16 for an answer. Now, if the horsepower went up to 1,000,000, which I know is impossible, but if you had 1,000,000 horsepower and you plug in 1,000,000 here, you're going to get negative gas mileage on that, which is something that you can't have. All right, so that's lesson 22 notes. Let me know if you have any questions.